I want you to explain to me this project in the context of data, right? You've explained the project, you've mentioned everything, but I want you to explain it in the context of the data, the relationship between the two. Please go ahead.
All right, thank you. So we received the data from the client, and that was in our CSV format, which is basically a text format. And we had approximately 2,500 rows and around 10 columns. And out of that, there were certain columns which were not required, like the car manufacturer name and all that. For doing the prediction, we don't need to have that information. So we eliminated certain columns and we zeroed in on 7 columns, out of which the one of the column that we wanted to predict was mileage. And we, as I explained, we used multiple linear regression, wherein it tried to bring up the mathematical equation to predict the mileage with the remaining 6 factors. And we evaluated the accuracy of the particular model by splitting the complete data that we had into train and test. And once we built the model, we compared the model's accuracies, and we found that the accuracies were fairly similar, accurate. And we had, as I mentioned, close to 95% accuracy on the training data set and around 80% accuracy for test data set. This is what we did, Mr. Nitin.
Okay. So that is probably the epitome or the highest level of how a wrong answer can be. The question was, talk about the...
My life be like...
I'm so sorry. The question was with reference to the the project with reference the activity or the project with reference to the data, and the explanation or the database was explained very briefly about rows and columns, which nobody is interested in, and then went off again into the modeling and the accuracy, etc., which was digressing. The question was the objective of the question was lost. So let us now listen to Mr. Inferior from 360-digit MG give an explanation about the project that he has done in the context of data.
Sure. So first, we have done appropriate research to understand what are the key variables which are needed for our analysis, and then we got those from the client. Nevertheless, while we were trying to analyze, the previous project that we have done was in the Indian context, and this project was being done from the US context for a US client. So the moment we got the data, we understood each and every variable, and we tried to understand the data set itself. We had 20,000 rows and we had 17 variables. Then while we were analyzing each and every column, we figured out that there was a column called as gender. And gender as such should not be used in the model building when it comes to loan default predictions, because then your model will be biased towards a specific gender. So we removed that. We also had a column called as date of birth. Date of birth as such wasn't making a lot of sense. So we converted that using feature engineering. And we have come up with a new variable, which is age in years. So that variable was making a lot of sense. And we also had a column called as income of a person. And when we have done analysis, we figured out that income was following an exponential distribution. And to capture the patterns of that variable, we had to do a log transformation. So we have also done transformation. In a few of the other columns, we had seen that a few values were missing. When we have gone back to the client saying that, hey, can we get back the data, get the data for the missing cells? They told that we don't have access to the data. So we had to do certain imputation techniques. And we have done, something called as, mice, which is one of the techniques for, doing imputation. And once we imputed, and once we have done outlier analysis, and once we have dealt with all the outliers using techniques such as Greensterization, etc., we got the right kind of data for our model building. So we prepared the data for our modeling phase. And once we got into the modeling phase, then we have split the data into training and test. Then when we trained on the data set, we have figured out or shortlisted a few algorithms which have the interpretation capabilities, because that was our end objective. We also wanted to build a model which has the interpretation capabilities. So for all these algorithms, then we figured out what are the various hyperparameters for decision tree and for logistic regression. And we have applied all those parameters, and then we have done a lot of experiments. We have done close to 120 experiments using grid search techniques, which will automate the experiments. And then ultimately, we have selected one algorithm which was giving us the highest accuracy. And we have selected that specific model, and then we have tested on the test data. We figured out that the model was giving very good accuracy of 90%. Then we have actually deployed the model in production. And then we have also given it to the client to experiment. And then they have experimented on a few other data points, additional new data points that they had, and they were happy with the results. And thereafter, we have deployed the model in production. And we have also maintained the version of the data, because if the client asks us to reproduce the results, the client says, hey, you're saying that you got 90% accuracy, go prove it once again before us by sharing your screen. For that, we need to ensure that the data version which we have used has to be maintained, and we have maintained the data versioning as well. Right? And one more thing which I've actually missed out was data validation. We wanted to figure out whether the data was of right quality or not. For this, we have done a lot of exploratory data analysis, and we figured out that as and how the age of the person was increasing, income of the person was increasing, the number of defaulters, the people who were defaulting, as and how the income increases, was actually reducing. So these kind of EDA techniques have actually helped us figure out that yes, the data was of good quality, and only then we have processed all these steps that I've just spoken about. And we've also clearly mentioned in the note saying that any future data coming would actually work only if the new data is within the range. For example, income, if it is in the range of $6,000 to $12,000, age, if it is in the range of 28 years to 36 years, only then it works. Because the data on which we have built the model was in that specific range. This is how we have given the project. And we have also mentioned notes saying that if you have more than 20% of data additionally getting generated, you have to retrain the model, because the model that we built cannot obviously work for the rest of the life. And thereby we have, one last thing was, we've also looked at what is it that we have promised to the client in the beginning, and did we actually achieve those success criteria or not. We have told them that we'll help you reduce the loan defaulters by 3%. Were we able to meet that or not on the test data? We also told that we'll help you get an accuracy of greater than 85%. Did we actually meet that or not? And we've also promised to the client that this would help you save approximately $500,000 to $600,000. And when we tested on the test data, it actually did. So whatever success criteria we have given has actually helped out. Yeah, thank you so much.